Hi, this is Janak Reddy Dubbaka. This is another lecture for Re-Neet students, that is atom. This is also one of the important topic and very limited syllabus and easy also. Now we are going to discuss some important problems from this chapter. See here, taking Bohr radius as A0 is equal to 53 picometer, the radius of lithium plus plus ion in its ground state on the basis of Bohr's model will be about. See here, radius in nth state Rn is equal to 0.53 n square by z angstroms. But whereas this is also 0.53 n square by z picometer. Therefore, here picometer is given, that is in lithium plus ion in ground state. Ground state means n is equal to 1. Therefore, R1 is equal to 53 into 1 square. For lithium, Z is equal to 3. Therefore, it is approximately 18 picometer. Second one. Hydrogen atom in ground state excited by monochromatic radiation of lambda 975 angstroms. Number of spectral lines in the resulting spectrum emitted will be. First, we have to find out for this wavelength what is the energy of photon. Energy of photon, that is equal to, when wavelength is given as an angstroms, 12,400 by lambda in angstrom, this becomes electron volts. Therefore, energy of photon is equal to 12,400 by lambda is 975. This becomes 12.75 electron volts. With this energy, if the electron in a ground state absorbing this energy, it excited to some another energy level. Therefore, here if it is excited to nth energy level, En is equal to from ground state plus energy of photon. Therefore, En is equal to first ground state minus 13.6, energy of photon 12.75. This becomes minus 0.85 electron volts. But this is the energy in nth energy state, that becomes minus 13.6 n square by z square by n square minus 13.6 z square by n square, that is equal to minus 0.85. Therefore, n square is equal to here z1 for hydrogen and 0.85, approximately 16. Therefore, here n is equal to 4. Means this electron is excited from n is equal to 1 to n is equal to 4. During de-excitation from 4 to 1, how many number of spectral lines emitted? That is capital N is equal to n into n minus 1 by 2. Therefore, n is equal to, here is n 4, 4 into 4 minus 1 2, that is equal to 6. Therefore, number of spectral lines are 6. Next one. The wavelength of first line of Lyman series for hydrogen atom is equal to that of second line of Palmer series for a hydrogen-like atom. The atomic number Z of hydrogen-like atom. See here, wavelength formula 1 by lambda is equal to Rz square into 1 by n final square minus 1 by n initial square. See, in this hydrogen spectrum, for a different series, Lyman series, Balmer series, Paschen series, for that one, there is a small trick is there. That is low BP, high BP. After this, circle this one. Here 1B is there, here 1B is there. Here also P and P. Therefore, here put A. This is R. Here is A. Therefore, this becomes Lyman series, Balmer series, Paschen series, Brocket series, Fund series. After that, gives the number to this series. Here is 1. This is 1, 2, 3, 4, 5. See, in this formula, n final, that n final should be our given number. If it is a Lyman series, 1. Balmer series, 2. N initial means for each series there is a maximum wavelength and minimum wavelength. Maximum wavelength means first line. Minimum wavelength means last line. For example, Lyman series, first line means your n initial, our number plus 1, that is 2. Second line means our number plus 2, 3, like that. For example, Balmer series. In Balmer series, first line means 2 plus 1, 3. And minimum wavelength, it is also known as series limit. For every series, minimum wavelength, the initial is infinity. Therefore, 1 by infinity, 0. First where Lyman series, first line. Therefore, here 1 by lambda, that is equal to R z square hydrogen, therefore z is equal to 1. 1 by n final is always our number, that is 1, minus in Lyman series first line means 1 plus 1 2, that is 2 square 4. It is equation number 1. For Balmer series also both having same wavelength, therefore lambda R into 1. For Balmer series our number is 2, therefore 2 square 4. But here for Balmer series, here second line means for our number to add, second line means 2, first line is 1, 2 plus 2 4, 4 square, here is 16. This is equation number 2. By equating 1 and 2, but here Lyman series hydrogen spectrum, but here Balmer series hydrogen like spectrum, but not z is equal to 1. Here R z square is here. R z square. Therefore, by equating 1 and 2, we can find out the z. Therefore, here z is equal to 2. Z is equal to 2. Next one. The ionization energy of the electron in hydrogen atom in its ground state is 13.6. The atoms are excited to higher energy levels to emit radiation of 6 wavelengths. Maximum wavelength of emitted radiation corresponding to transmission. Here, number of spectral lines is 6. Therefore, n is equal to n into n minus 1 by 2. N is given as 6. That is n into n minus 1 2. Therefore, here n is equal to 4. N is equal to 4 means it is excited to 4th energy level. This is 1. This is 2. This is 3. And this is 4. 4th energy level. For de-excitation, there are 6 spectral lines. Like this. Therefore, these are the 6 spectral lines. In this, maximum wavelength means the energy difference should be minimum. Between 4 and 3, there is a minimum energy difference. Therefore, that is 4 and 3. Therefore, answer is from 4 to 3. Here is one trick. If the length of the line is minimum, that is having maximum wavelength. If the length of the line is maximum, that is minimum wavelength. Therefore, here this is the maximum wavelength and this is for a minimum wavelength. This is another trick. Next one. See, the ground state energy of hydrogen atom is 13.6. When its electron is in first excited state, its excitation energy. See, excitation energy delta E is equal to, for example, it is excited to nth energy state from ground state. Therefore, En minus E1. Therefore, delta E is equal to, here First excited state means n is equal to 2. Therefore, this is E2 minus E1. Therefore, delta E energy level, second energy level, that is minus 3.4, and one state, ground state is minus 13.6. This becomes 10.2 electron volts. See, if you don't know minus 3.4, very simple. E2 is equal to minus 13.6 Z1 by 2 square 4. Therefore, minus 13.6 by 4 minus 3.4 electron volts. Next one. A hydrogen atom and a lithium 2 plus ion are both in second excited state. Both in second excited state means the principal quantum number n is equal to 3. If these are LH and Li are their respective electronic angular momentums, E and EH and EL are their respective energies. Here, angular momentum L is equal to NH by 2 pi. Therefore, both are in third energy level. Therefore, angular momentum L is equal to constant. L is equal to constant means angular momentum for hydrogen, angular momentum for lithium, both are same. Therefore, in option same B and C. Therefore, A and D are wrong. See here. Next, here energy is equal to energy, nth energy n is equal to minus 13.6 Z square by n square. But here both are in third energy level. Therefore, here n constant, this one constant. Therefore, En proportional to Z square. Therefore, lithium having the atomic number Z is equal to 3, hydrogen 1. Therefore, E lithium is greater than E hydrogen. Means E hydrogen less than E lithium. Therefore, answer B correct. This one wrong. Next, the radius of the orbit of an electron in hydrogen-like atom is 4.5 a0, where a0 is the Bohr's radius. Its orbital angular momentum is 3h by 2 pi. It is given that h is Planck's constant, r is Rydberg constant, the possible wavelengths. Here, L is equal to 3h by 2 pi, means nh by 2 pi, n is given as 3. And here radius of orbit, that is 4.5 a naught is equal to a naught into n square by z. Therefore, here this is a naught cancel, z is equal to n square by 4.5, but n is given as 3, 3 square 9 by 4.5. Therefore, z is equal to 2. Next one, n is equal to 3 means 1, 2, 3. During de-excitation, these are the spectral lines. For this one, I am taking lambda 1, lambda 2, lambda 3. First, we have to find out lambda 1. Here I am taking 1 by lambda 1 is equal to rz square. Z is equal to 2 means 4. Therefore, here 1, 2 to 1, final value is 1. Therefore, 1 by 1 minus 2 to 1, 1 by 4. This becomes 4r by 3 by 4. Therefore, 4 gets cancelled. That is 3r. Therefore, lambda 1 is equal to 1 by 3r. But there is no option. Next, for lambda 2. 1 by lambda 2 is equal to 4 into r. See, here lambda 2 means 3 to 1. Therefore, 1 by 1 minus 1 by 9. This becomes 4r into 8 by 9. Therefore, this becomes 16r by 9. Therefore, lambda 2 is equal to 9 by 16r. Therefore, option B is there. Another one, lambda 3. 1 by lambda 3 is equal to 4r into, here lambda 3 means 3 to 2. Therefore, 1 by 4 minus 1 by 9. This becomes 4r into 9 minus 4, 5. 5 by 36. Therefore, 4, 9 times. Therefore, here lambda 3 is equal to 9 by 5r. Therefore, answer C also correct. Therefore, here B and C correct. Next one. A neutron moving with a speed v makes head-on collision with a stationary hydrogen atom in ground state. The minimum kinetic energy of the neutron for which inelastic collision will takes place is using conservation of linear momentum. Here, this is the neutron. Here is hydrogen atom. It is in ground state. Initially, it is at rest. Neutron is moving with velocity v. Here, neutron and hydrogen both having same momentum. Initial momentum m into v. This momentum is 0. Here, we consider a perfectly inelastic collision in that both the neutron and hydrogen stick together, move with common velocity. Therefore, m plus m into v dash. Therefore, v dash is equal to v by 2. Here, loss in kinetic energy delta k is equal to initial kinetic energy is half mv square. Final kinetic energy 1 by 2 2m into v by 2 whole square v square by 4. Therefore, this becomes delta k is equal to 1 by 4 mv square. This is the loss in kinetic energy. See here, electron in ground state, it is excited from ground state to minimum energy level, that is 2. Therefore, 1 to 2. For this one, the energy is equal to 10.2 electron volts. This energy loss must be equal to this minimum energy 10.02. That is equal to 1 by 4 half mv square is equal to 10.2 electron volts. This loss must be equal to 10.2. For this loss of energy, what is the initial energy of the neutron? That initial energy is half mv square. Therefore, half mv square into 1 by 2, that is 10.2 electron volt. Here we have to find out half mv square. Therefore, half mv square is equal to 2 into 10.2, that is equal to 20.4 electron volts. Therefore, if the neutron having the minimum energy of 20.4, then hydrogen atom is excited from ground state to first excited state. This is the minimum energy which is having the neutron. Next one. The de Broglie wavelength associated with the electron in n is equal to 411. Therefore, here for de Broglie wavelength, lambda proportional to n. Therefore, lambda 1 by lambda 2 is equal to n1 by n2. Therefore, lambda 1, lambda 2, n1 is ground state, n2 is fourth energy level 4. Therefore, lambda 2 is equal to 4 lambda 1. It is 4 times of de Broglie wavelength of electron in ground state. Option B correct. Next one. Energy required to remove the electron from single ionized helium atom is 2.2 times the energy required to remove an electron from helium atom. The total energy required to ionize helium atom completely. See, when first electron is removed, the energy required E1 is equal to 13.6 Z square by N square. That is 13.6 Z is here it is given as helium. Therefore, helium 2 square, N is equal to 1. Therefore, E1 is equal to 13.6 into 4. This becomes 54.4 electron volts. This is energy for to remove the electron from single ionized helium. Next one. Here it is given as energy required to remove the electron from single ionized helium atom is 2.2 times the energy required to remove the electron from helium atom. This becomes, this helium atom energy E1 is equal to 2.2 times of energy remaining electron, that I am taking E2. Therefore, E2 is equal to E1 by 2.2. E1 is 54.4 by 2.2. This becomes 24.73. Therefore, total energy required to remove both the electrons E is equal to E1 plus E2. First electron removing energy, that is 54.4 electron volts. For removing the second electron, that is 24.73 electron. Therefore, total 79.13 electron volts. This is the total energy to remove both the electrons from the helium atom. Next. So, a stationary hydrogen atom undergoes a transition from n is equal to 5 to n is equal to 4. Recoil speed of the atom is, see here, first delta E is equal to, in terms of C, this becomes RHC into 1 by n final square minus 1 by n initial square. Therefore, delta E is equal to RHC into n final is 4, 16 minus initial is 525. This becomes RHC into, this becomes 25 minus 16. This is 9 by 25 into 16, 400. 9 RHC by 400. This is the energy level between 4 and 5. But here, momentum of atom is equal to momentum of photon. But momentum of photon, that is equal to delta E by C. This is the energy when n is equal to 5 to n is equal to 4, energy of photon delta E, therefore delta E by C. This momentum is equal to momentum of atom, that is equal to delta E by C. Delta E means RHC into 9 by 400 into C. Therefore, this C cancel. Momentum of atom is equal to momentum of atom is equal to 9R h by 400. Therefore, here momentum means mass into velocity, that is equal to 9R h by 400. Here V is the recoil velocity of the atom. V is equal to 9R h by 400 m. This is the recoil velocity, 9R h by 400 m. Option C is correct. Next one. If lambda 1, lambda 2 are wavelengths of photons emitted when electrons in nth orbit of hydrogen atom fall to first excited state and ground state respectively, then the value of n is. See, first one, 1 by lambda 1 is equal to RZ square into n final square minus n initial square. See, lambda 1 are the wavelength of photon when electron in the nth orbit of hydrogen atom fall to first excited state. First excited state means n is equal to 2. Therefore, 4 minus 1 by n square. It is equation number 1. 1 by lambda 2 is equal to RZ square into here and ground state means 1 by 1 by n square. It is equation number 2. Therefore, from these two equations are dividing 1 by 2, we can get the answer n is equal to square root of 4 into lambda 2 minus lambda 1 by 4 lambda 2 minus lambda 1. Therefore, answer C correct. Next. The acceleration of electron in first orbit of hydrogen atom. See here electrons are revolving in a circular path. Acceleration means centripetal acceleration. That centripetal acceleration that is V square by R. Here we have to find out V. Therefore, MVR is equal to NH by 2 pi. From this, V is equal to NH by 2 pi mr. This is the velocity. Therefore, AC is equal to 1 by R into V square. V square means N square H square by 4 pi square M square R square. This becomes N square H square by 4 pi square M square R square into R cube. Therefore, N square H square acts in the first orbit means N is equal to 1. Therefore, this becomes AC is equal to H square by 4 pi square M square R cube. H square 4 pi square M square R cube. Therefore, answer C is correct. Next one. The distance of closest approach of an alpha particle fired towards a nucleus with momentum p is r. What will be the distance of closest approach when the momentum of the particle is 2p? See, at the closest approach, kinetic energy is equal to potential energy. Kinetic energy means p square by 2m. Potential energy 1 by 4 pi epsilon q1 q2 by r. Therefore, here p square proportional to 1 by r. Therefore, here r1 by r2 is equal to p2 by p1 whole square. Here r1 is r. We have to find out r2. p2 is 2p by p whole square. This is 4. Therefore, 4 by 1. Therefore, r2 is equal to r by 4. Therefore, answer D correct. Next one. Hydrogen atom in its ground state is excited by means of monochromatic radiation of energy 12.75. The minimum energy of the emitted spectral lines is nearly same. Here En is equal to E1 plus energy of photon. Therefore, En is equal to E1 is minus 13.6, energy of photon 12.75. This becomes minus 0.85. Minus 0.85, En is minus 13.6 Z square by N square, that is equal to minus 0.85. It is a hydrogen, therefore Z is equal to 1. N square is equal to 13.6 by 0.85, approximately equal to 16. Therefore, N is equal to 4. Therefore, here 1, 2, 3, this is 4. Therefore, it is excited from ground state to N is equal to 4. Here, the minimum energy emitted spectral lines mean that is the energy between this one, E4 minus E3. Therefore, delta 4 is equal to E4 minus E3. E4 is minus 0.85. E3 is minus 1.51. Therefore, this becomes, this minimum energy is 0.66. 0.66 electron volts. Next one. If the first excitation potential of a hypothetical hydrogen-like atom is 15 volts, then the third excitation potential, see here excitation energy delta E, that is nothing but En minus E1. Therefore, this becomes delta E is equal to En minus E1, this becomes 13.6 Z square 1 minus 1 by N square. Therefore, delta E, this excitation potential is given as 15 volts. 15 when it is excited from first excite, if the first excitation potential, first excitation means N is equal to 2. This becomes 13.6 Z square 1 minus 1 by 2 square 4. Therefore, this becomes 13.6 Z square into 3 by 4. Therefore, this becomes 3 5 times 13.6 Z square is equal to 5 into 4. This is 20. Then we have to find out third excitation potential. The third excitation potential 13.6 Z square into 1 minus third excitation means N is equal to 4. This is 16. Therefore, 13.6 Z square into 15 by 16. Therefore, this becomes 13.6 Z square is equal to 20 into 15 by 16. 4 5s are 4 3s are 15 into 5 75, sorry, 4 75 by 4 volts. Therefore, answer D correct. Next one. The speed of electron in a first Bohr orbit is given by 2.18 into 10 to the power of 6. If the time period of electron in nth orbit is measured as 4.10 femtosecond, then the value of n is. Here, time period t proportional to n cube. Therefore, T1 by T2 is equal to N1 by N2 whole cube. Here, T1 is the first Bohr's orbiter. Therefore, that becomes T is equal to 2 pi R by V. That is 2 pi. R is a first radius of the first Bohr orbit. That is 0.53 angstroms. That is 10 to the power of minus 10. Velocity is given as 2.18 into 10 to the power of 6. After simplification, we can get T1 is equal to 1.52 into 10 to the power of minus 16. Here, T1 by T2, 1.52 into 10 to the power of minus 16. And here, T2 is given as 4.1 femtosecond. 4.1 into 10 to the power of minus 15. N is equal to 1 by N whole cube. So, after simplification, we can get N is equal to 3. Next one. Monochromatic radiation is incident on a hydrogen sample which is in ground state. If the hydrogen atom emits radiation of 10 different wavelengths after absorbing incident radiation, then the wavelength of incident radiation is. Here, number of spectral lines n is equal to n into n minus 1 by 2. Here, n is given as how many number? 10, that is equal to n into n minus 1 by 2. From this n is equal to, we can get n is equal to 5. If the hydrogen atom emits radiation of 10 different wavelengths after absorbing the radiation, then the wavelength of incident radiation is. First, we have to find out delta E. That delta E is equal to E5 minus E1. E5, fifth energy level, that is minus 0.54, minus of minus 13.6. That delta E is given as 13.06 electron volts. For this energy, we have to find out wavelength. So, lambda is equal to, here Hc is given as 1242. Therefore, 1242 by 13.06, we can get a nanometer. Therefore, lambda is equal to 95.1 nanometer. Next, ionization energy of lithium atom in ground state is 5.4. Binding energy of electron in lithium plus ion in ground state is 75.6 electron volts. Energy required to remove all the 3 electrons in lithium. See, first one, for removing one electron, that E1 is given as 5.4. And lithium plus means second electron to remove, E2 is equal to 75.6. And remaining third electron to remove, that is 13.6 Z square by N square. Therefore, E3 is equal to 13.6, Z is equal to lithium 3, 9, N is equal to 1. Therefore, E3 is equal to 122.4. Therefore, to remove the 3 electrons, total energy required E is equal to E1 plus E2 plus E3. E1 is given as 5.4, E2 is 75.6, E3 122.4. Therefore, total energy E is equal to 203.4 electron volts. This is the total energy required to remove all the 3 electrons. Next, this is also very important one. Orbits of a particle moving in a circle are such that perimeter of orbit equal to an integral multiple of de Broglie wavelength of the particle. For a charged particle moving in a plane perpendicular to magnetic field, the radius of nth orbit will be therefore proportional to 1. Therefore, here circumference 2 pi r is equal to integral multiple of de Broglie wavelength n lambda. Therefore, 2 pi r is equal to n lambda, n into lambda h by mv. Lambda is equal to h by mv. But in a circular path, radius r is equal to mv by bq. From this, mv is equal to bqr. Therefore, 2 pi r is equal to n into nh by mv, that is bqr. Therefore, here b proportional to, for a charged particle moving a plane perpendicular to the radius of the nth orbit will be therefore radius of c. Here this r, this r. Therefore, r square. R square proportional to n. Therefore, r proportional to n to the power of 1 by 2. R proportional to n to the power of 1 by 2. It's a very important one. And this is also very important. According to Bohr's theory, the time averaged magnetic field at the center of nucleus of hydrogen atom due to the motion of electron in nth orbit is proportional to, see here at the center of the nucleus, magnetic induction B is equal to mu naught I by 2r. But if electron is revolving in a circular path, equivalent current I is equal to EV by 2 pi r. Therefore, here B is equal to mu naught by 2r. I means EV by 2 pi r. Therefore, here B proportional to V by r into r square. B proportional to V by r square. Here V proportional to V by r square. But V proportional to 1 by n, r proportional to n square, here n square. Therefore, B proportional to V is 1 by n, r proportional to n square, therefore n to the power of 4. Therefore, B proportional to 1 by n to the power of 5. Therefore, B proportional to n to the power of minus 5. Therefore, answer B correct. So, these are the important problems for atom. Okay, thank you.